Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 9-5 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to complete the square when a is not equal to 1 initially. Alright, so I kind of don't like that they introduced this with a word problem, but that's fine. Alright, so there's this maze that has like a two-yard walkway that goes around it. Alright, and they want us to figure out the dimensions of the maze. So the first thing worth noting, it says the length of the hedge is twice as long as the width, and then they give us the total area of the maze. Now this maze is in the shape of a rectangle, so to find the area of a rectangle you would do the length times the width. So if I can find expressions for each of these things, I can plug them into this formula and call it good. Now they tell us what the area is, right? They call it 5,616 yards squared. My expression for my length, alright, now remember the length is twice as long as the width. So I'm going to go ahead and I'm going to call the width an expression, and then I'm going to double it to get my length. So let's look at the width. So I have a width, but remember there's 2 yards on each side of it for the walkway. So all the way across would be some expression plus 2. And so my length is going to be double that. So I would have 2x plus 4 for my length. Alright, so now I'm going to go ahead and, that should be x plus 4, right? Because it's 2 here and 2 there. Sorry about that. And so now I'm going to go ahead and plug each of these expressions into my area formula. So when I go to do that, I get my area, which is 5616, is equal to my length, which is 2x plus 4, times my width, which is x plus 4. And so my goal now is to go ahead and, calculate it, figure it all out. The first thing I'm going to do here is I'm actually going to distribute this part. So I'm going to go to the side real quick and probably use the box method to multiply those together. So I'm multiplying 2x plus 4 and x plus 4. So 2x times x is 2x squared. X times 4 is 4x. 4 times 2x is 8x, and 4 times 4 is 16. So this part here is 2x squared plus 8x and 4x is 12x plus 16. Now I realize I'm a little bit vague about where these expressions come from. I'm calling the width x, but then adding 4 for the walkway. So on the length where it's double the length, that's where the 2x is coming for, but then I have to add the 4 for the walkway. Don't put an 8 here because that 4 was not doubled, okay? Alrighty, so now we have this expression. So the first thing that I tend to do when I have expressions like this is we have 2 goals. The first goal is to make it to where there's no number in front of the x squared. The other is to get our x's alone. So whichever order you prefer is totally fine. I see the 16 and the 16 and I'm like, let's get that bread. Alright, so I'm going to go ahead and subtract by 16 from each side. So on the left-hand side, I'm left with 5600, and on the right-hand side, I'm left with 2x squared plus 12x. Now, we've only learned how to complete the square when it's 1x squared. So instead of freaking out about it, let's just divide everything by 2, and then we'll have the expression that we need. So 5600 divided by 2 is 2800. Alright, and then I have x squared plus 6x. And so now we can complete the square, right? I can I can add some kind of value that's going to turn that right-hand side into a perfect square trinomial. So I'm going to take that b value, divide it by 2, and then I square that to get 9. And so that is what I'm going to be adding to each side of the equation. All right, so on the the left-hand side, I have 2,809. And on the right-hand side, this is now a perfect square trinomial, right? It's going to turn into an x, and then this first sign's a plus, and 6 divided by 2 was 3. All right, so we have completed the square now. Now we need to go about solving. So I'm trying to get that x alone so that I know what my width is. Okay, so firstly, we want to get rid of that square root. Get rid of that square. And so to get rid of the square, I'm going to take the square root. Now don't forget to put your plus or minus on your expression. Oops. You only need it on one side though. Now if I actually take that square root in my calculator, the square root of 2809 is actually 53. So that is a very solid just whole number, which is nice. And then on the right hand side I have x plus 3, because the square root and the square cancel each other out. So then my next thing would be to get the x alone, so I'm going to subtract 3 on each side. And so I have negative 3 plus or minus 53 is equal to x. Now, you guys have seen from previous examples, usually it's left in some kind of form like this, but 3 and 53 can actually be combined, right? Like I can actually do that addition, or I can actually do that subtraction. So in a situation where you actually get like a whole number, we're going to go ahead and split it and do it. All right? So I'm going to create two solutions. One where I have negative 3 plus 53, and one where I have negative 3 minus 53. And those will be my two x values. So negative 3 plus 53 is 50, and negative 3 minus 53 is negative 56. Now let's think about kind of the context of this problem. We're talking about the lengths of a maze, right? Like the sides. Can I measure something and get a negative length? No, that wouldn't make any sense, right? So a negative value won't make sense in the context of this problem. So my only viable solution then would be the 50. So what I would do is I would answer this, because it's a word problem, I'm answering it with a word solution. The length of the maze is 50 yards, and the width, remember the width was double? Oh no, the length was double. Dang it. So the width of the maze is 50 yards, and then the length is double the width, so, and the length is 100. Okay, so let's see if we can do that again here with the try it. So it's the same expression, same thing where it's the length is twice the width. All right, but they're changing our walkway to being 1 yard wide. All right, so we're still using that the area is the length times the width. We're still using that the area is 5616. Okay, our width is going to be x, and then we're adding our walkway to it. Now the walkway is only 1 yard out, so that's how they're changing it, is this is now x plus 2 instead of x plus 4. And then my length is twice that width, so 2x, and then it has that walkway rounded of 2. So if I'm writing out this expression, I have that the area is equal to the length times the width. All right, so first thing I want to get rid of those parentheses. So I'm going to take those to the side and use the box method to, don't judge me how I drew that box. I'm going to use the box method to actually do that distribution. So x times 2x is 2x squared. X times 2 is 2x. 2 times 2x is 4x, and 2 times 2 is 4. And we're going to combine those middle ones, right? So I get 2x squared plus 6x plus 4. Alright. See, this is why I didn't like this problem, because all of that was just to get an equation. Whereas really I wanted my students to focus on how to complete the dang square. That's fine. So here we go. So remember, we want to get our x's alone, and we want to divide out whatever our a value is. It doesn't matter the order in which you do that. So I'm going to go ahead and subtract the 4 right away, because subtracting 4 is easy in my head. So I get 5612 is equal to 2x squared plus 6x. And then we're going to go through and divide everything by that a value. So my a value is 2, so I'm dividing everything by 2. Also opening up my calculator because I don't know that one off the top of my head. Alright, so 5612 divided by 2 is 2806. And I'm going to try to remember to leave a little space, right? Because remember, when we complete the square, we add to it. And then 2x squared divided by 2 is x squared. And 6x divided by 2 is 3x. Oh, and they really want to make this ugly. Do you see how that's like odd number? When I go to complete my square, I'm going to be adding to those, aren't I? And so what's going to happen is I'm going to end up dividing that 3 by 2, and I'm going to get a decimal number. Are we going to freak out about the decimal number? No. Is it going to suck to deal with the decimal number? Yes, but just be aware of that. That's why I'm getting a decimal, is because this turned out odd. Alright, so I'm going to take 3 and divide it by 2, just like we normally do. That's about 1.5. And then I'm going to take 1.5 and I'm going to square it. So 1.5 squared is 2.25. Now, you can do this either as a decimal or a fraction. I usually prefer fractions, but for the sake of this video, I'm trying to keep it as clear as possible for students. So on the left-hand side, I just add those together, okay? And then on the right-hand side, this is going to turn into a perfect square trinomial, right? It's x plus 1.5 squared. So we have completed the square, and what it's done is it's created decimals, which is kind of ugh. But we can deal with that. We can manage that. Alright, so now we want to get rid of the square by taking the square root. Don't forget to put your plus or minus in front of your number. And so when I take this square root, I know it's going to be ugly. Like, I know it's not going to be what I ideally would want. That's hideous. But okay, we're going to do it. So the square root of this is a very, very long number. It goes on for forever. So I have to actually round this. So I'm going to go out by 4 digits just so that I really, really get a precise solution. In the end, they want it in terms of tenths, although they never specifically state that. And then my last step is to get rid of that 1.5, so I'm going to subtract 1.5. Alright, now these two values, they're just decimals, so I can combine them. So I'm going to split this into two equations. So I have negative 1.5 plus 52.9929. And I'm going to have negative 1.5 minus 52.9929. Alright, so on that first one, I get 51.4929 for my x value. And on this second one, I get negative 54.4929. So if we think about the context of our problem, we can't use the negative one. So I'm going to round this to the nearest tenth, just because that's what Savvas does, and then we're going to answer our question. So the width of the hedge, or the maze, is about 51.5 yards, and the length is double that. So if I'm calling it 51.5 and I times that by 2, my length is about 103 yards. So there we have it, guys. That is how to complete the square when A is not 1. Until next time.